Hello, thank you both. Thanks for joining our session today. I'm Lily, and I'm joined here by my colleague Anthony, and we'll be talking about hosting remote MCP servers. Um, so you've probably heard about MCP in previous sessions already, so we're just going to give a very quick overview of what it is in case you didn't catch that. So MCP, or Model Context Protocol, is a standard for AI agents to connect to external tools, data, or system. The way these resources are provided is through the MCP servers, which you can think of as APIs wrapped in a standard format that is easy for agents to consume. So there are two main transport types for MCP servers. One is the STDIO. So this is typically used when your server runs next to the agent and on the same compute, and it's started by the agent as a sub-process. The other transport type is streamable HTTP. You would use this when you want your server to be used by multiple agents. So perhaps in an enterprise scenario, you want different teams to be able to use your server, so you would implement it using this transport. So today we're going to talk about the streamable HTTP servers today. And because the MCP servers run over HTTP and can be deployed basically to anywhere that runs HTTP, there are many hosting options. We are going to focus on Azure Functions today. So, first question first, why functions? What are the benefits of hosting on functions? I'm going to highlight a few here. So the first is built-in server authentication and authorization. So functions has integrated with a feature that implements the requirements of the MCP authorization spec. So you don't have to do that. Just enable the feature on the function app and you get the server auth kind of out of the box. The other thing is function scales very fast from 0 to n, especially with the flex consumption plan. So it can handle any bursty traffic that your server may have and also scale back down to 0 when needed. And the best of all is you can just pay for what you use. So there are two types of servers that can be hosted remotely on functions. One are servers built with the Azure Functions MCP extension. If you are familiar with functions, you might know about the concept of triggers and bindings in the functions programming model. And that's what the MCP extension kind of provides. It provides this MCP tool trigger for building servers. And my colleague Anthony will kind of show a demo of that later. The other type of server that can be hosted on functions are those built with the standard MCP SDKs. So this option is great for people who have already built their servers with the official SDKs, or they're more familiar with those SDKs, and now they're just looking for a place to host the servers remotely. So I'm going to show a demo of that right now. Switching over to VS Code. Um, so let me make this in Zen mode. Uh, so I have implemented a weather server using the .NET MCP SDK. If you like the other languages, you can also use Python, TypeScript, or Java. The hosting experience that I'm going to show you will apply to those languages as well. So what I'm going to do is I'll walk through the server code very quickly, and then I'll show running the server locally, test it, and then deploy it, and we'll talk about the auth part. So here I have my program.cs. Basically, I have set up an ASP.NET app and registered a bunch of services, one of which is the MCP server. I'm using the streamable HTTP transport here, and the server is stateless. So this is important because right now your server must meet these requirements to be hosted on functions. And I have some tools and a bunch of services that my tools will use, and some endpoint. I guess the key one is the /MCP one, because that's where the server, that's the server's endpoint. So now let's hop over to look at the tools. So basically MCP server tools are just methods that you define, but with this decorator, MCP server tool, and a description of what the server does. So this one gets the weather of a US state. You would give it kind of the two-letter abbreviation for the state, and then it would return you any weather alerts. And this other one takes in the longitude and latitude of a location and then returns the weather forecast. So now let's run the server locally to see what happens. I have already built the project, so I'm just going to do .NET Run. All right. Let's hope it works. Okay. So it's running the server and listening on this endpoint. Um, I'll connect to the server. VS Code has a command that allows you to do that very easily. So you just open the command palette and choose the MCP add server, and then choose your transport, and then put in this URL. I've already done that, so I'm just going to hop over to the JSON file and start the server. So as you can see, it discovered 3 tools. And so I'm going to test those tools. Let me first make sure the local server is picked for my chat. I am in New York right now, so I'm going to ask it temperature of New York City this weekend. And let's see if Copilot knows to use the tools. Okay, so indeed, it figured out that, okay, I can use this get forecast tool for my local server, and it gave the I guess the coordinates of the location. So I'm gonna allow it, and let's see. Okay, so looks like it's gonna be sunny Saturday, but rainy on during the night. So here we have the server running, and we just tested locally. Now let's see how we can deploy this. So I'm gonna stop it first. Okay, so for deploying this the server to functions, the only file you need to add is this host.json file, which basically tells the functions host how to run your server and where, for example, which port to listen to. Um, One thing to note is when your server is deployed to Azure Functions, it's deployed as a custom handler, which you can think of as a lightweight web server that handles requests from the functions host. And yeah, and so that is all you need to deploy your server. There's no code changes. You just need to add this file. So you might notice that we have this infra folder here, which basically defines all of the bicep files that are needed for the required resources to be provisioned. And so with all of the biceps that we have, we can just do azd up, and that will kind of provision all the required resources and deploy your server. So I'm going to do that. If you're not familiar with AZD, it's the Azure Developer CLI. So you can see it kind of started packaging stuff, and it's going to kind of start the provisioning. I'm not going to wait for it to finish because it does take a few minutes. I'm just going to show you a resource group that's already provisioned. So as you can see here, I have a bunch of things provisioned. The hosting plan, the function app itself, which is the server, and other resources like App Insights that provides execution insights. So I'm going to go into the app and then grab the domain, and then head back to VS Code to test it. I'm going to close this for now. So if I hit start, it's going to ask for the domain of the app. So I'm gonna give it that domain that I just copied. And we can also show output here, which kind of shows the interactions between the client, VS Code in this case, and the server. So just like before, it discovered the tools. Uh, so let me also test this remote one. Okay, so let's say weather alerts, maybe in Washington this time, and see if it can identify this remote server and the tools that it has. Okay, so as you can see, VS Code Copilot did figure out that it can use this get alert tool from the remote server, and the state that we wanted is Washington. So I'm going to allow that. Um, Looks like there's no active alerts at the moment. So right now we have kind of the same weather server that I showed locally, but it's running in the cloud. Um, One question that you might be thinking right now is, well, okay, I have this server, but it doesn't look like it has any auth, which means like anyone with this endpoint can access my server. And you would be right. In this case, it's probably okay because it's just a weather server that returns the weather. But in like an enterprise scenario, this is definitely not secure. So I'm going to show you kind of another server that I deployed that has that auth layer to it. I'm going to stop this. Um, so I just deployed this other weather server, and I have configured it with the built-in auth feature that I mentioned before. And I chose kind of Microsoft as the identity provider. So let's see what happens when I try to connect to this server. Um, So I'm going to let me clear this and give this new server URL. Okay, so for this time, I am asked to authenticate to Microsoft. So I'm going to allow it and then pick my account. Maybe let me stop it and restart it because it's hard to see with all the traces. So let me restart. Okay. Um, so the thing that I kind of want to show you, that like to point out what happened during this authentication flow is so you can look through this trace in more details yourself, but I'll kind of just walk through the high level flow. So what happened was when you first try to connect, the server is like, oh no, you have no access. So it returned to 401. But then in the header of the response, it also has this resource metadata URL, which tells the client, which is VS Code in this case, where to look for the identity provider, which is Microsoft Entra. And so that was why I got prompted to authenticate with Microsoft. And Entra gave VS Code an access token. So I think there's a bunch of steps that happen here to get the access token. And in the end, when it was able to get the access token, it populated the kind of a new request with that token and sent it over again to the server. And then this time around, the server was like, okay, you have access. So we got connected, and then there's a bunch of kind of interactions to the server to get the tools. So that's kind of how the server authentication flow looks like. But let's go one step further. So let's say you have a tool that the client, in this case, VS Code, wants to use, but it requires access to some downstream service, right? So how does it do that on behalf of the user? So that's the final thing that I wanted to show you. This is this on behalf of flow. Um, so I actually have another tool that I did not mention before, but this tool uh, It's called user info tools. But what it does is it gets the information of the logged in user from Microsoft Graph. So in this case, we somehow have to access Microsoft Graph to get the information. Um, so the token that VS Code got from Entra to access the server is not enough because the audience of that token is the server, not Graph. So what we need to do is we need to do an exchange. So we use that token that VS Code used to exchange for a token that Graph can use to make the downstream call. So that's what this code is basically doing. First, grabbing the header, um, and then kind of parsing the auth token that VS Code got from Entra, and then using this on behalf of credential object from the Azure Identity package to do this token exchange. So here I passed in the information of the Entra app registration. There is also a client assertion, which basically takes the managed identity of our MCP server app and gets a token. And then obviously our VS Code token to do the exchange. And with that, we can get a graph token with the right scope and the right audience, which is Graph in this case, and make the call to Microsoft Graph to get information about the user. So let's see kind of what happens when I try to use this tool. Let me. This should be the right server. So double check. Okay. So I'm going to say use remote server to return info about me. Okay. So looks like it identified that this is the tool to use. And let's see what happens when I allow it. It says you're not currently authenticated. So we need to authenticate and give consent before VS Code can invoke that tool. So I'm going to go to that URL and give my consent. Accept. Okay, and then head back and until I'm done. Okay, looks like it doesn't really understand that. I would say just ask it again. And then see if okay. So this time around, it's able to get the information using the tool. So that concludes my demo. So to recap, I showed you how to run MCP server locally and then deploy it. And then I showed how to configure that server with the built-in auth feature that that provides this authentication flow when you connect to the MCP server. And then finally, I showed you how to do the token exchange to have this kind of on behalf of flow. If your agent or VS Code in this case tries to call a tool that needs to reach a downstream service. So now I'm gonna kind of let my colleague Anthony take over and show you the MCP, the functions MCP extension.
Thanks, Lily. Yeah, so what we just saw from Lily is how to run basically just a standard MCP server that's built in .NET and have that hosted in a function app. But if you are already a functions developer and you already have a function app, or really if you're just looking for a really simple way of turning just some existing code into a tool that's available in an MCP server, you can actually do this with the Azure Functions extension for MCP. So I'm going to quickly show you that today. So here I have an Azure Function app that's built using .NET. Um, it already has a couple of HTTP functions in there. In this case, again, we're just getting the weather. But this is just a plain HTTP function. But using the MCP extension, I can also add a function that has an MCP tool trigger. And just by adding this MCP tool trigger attribute onto our function here, it automatically turns this function into an MCP tool. And here I'm also asking for the latitude and the longitude. And we're also able to provide descriptions so that that gets built into the metadata so that the agent can understand what it needs to pass in order to call our MCP tool. And then that's it. Both of these functions call into the same helper function to get the weather. So we're actually getting a lot of code sharing here. So in this case, we're actually going to be able to deploy a single function app that's able to serve up both just regular HTTP requests, but it can also act as an MCP server. So the other piece that's needed here in order for this to run as an MCP server is just a little bit of information in the host.json file. Just to kind of configure the MCP extension so that it can basically add more things into the metadata. In this case, a server name, as well as just a quick description of what's in that server. Again, that makes that information available to the agent so that it's able to pick the right server and the right tool when it needs to do the right thing. Out of the box, and any tools that you create using this trigger will require an API key to call. In our case, we're actually going to put the same Entra authentication in front of our application that Lily just showed us. So I'm actually going to set basically the webhook or the API key requirement to off using this setting. And that's pretty much it. And then I deploy this to Azure. And here's the app right here. You can see here that our functions that we defined are already appearing in the portal. I think pretty much everything else Lily has already showed you, so I'm not going to repeat that, but I'll just kind of quickly show you that the authentication here has been configured as well. So it's been configured using Entra so that any requests that are coming in, if it doesn't have a valid token, it's going to get denied with the 401. Okay, so I already have this app deployed, and I've already added it to my mcp.json. So I'm going to go ahead and start it. And you can see here that it's asking for me to log in. So it's just going to use my login from VS Code, just like the app that Lily showed you, which is no surprise because it's using the exact same feature. But you can see here that it's discovered our tools. And I'll kind of quickly go and use this tool. So, tell me information about myself using a tool. So hopefully that will get VS Code to invoke this tool. And there it goes. And I'll say allow, and it's going to go off and call our MCP server and get the answer back. And we can actually see the raw response by expanding it here. So yeah, so it's really just the same. You kind of get the same functionality as what you can get with running a standalone or basically like a standard MCP server that you would build with the .NET SDK. But if you're already a functions developer and you want to take advantage of the functions programming model, including bindings, this is a great way to deploy your MCP servers. All right, so and to wrap up, I think a lot of what we just showed you is available in this repo here, aka.ms/remote-mcp. Please go try them out and let us know what you think.